In this nugget, we are going to learn about removing networks from the Docker host. First, let's try removing the default network from the host. So let's get back to our host. First, I'll run the Docker network ls to list the available networks on this host. Okay, so out of these, the bridge, host, and none are the default networks. Now, command to remove networks is docker network rm followed by either network name or network ID. I will run the docker network rm host. Okay, so we get the message that host is predefined a network and cannot be removed. Same would be in case if I try to remove bridge or none networks. Okay, so we understand that predefined networks cannot be deleted, but custom created networks can be deleted. We have new bridge 1, new bridge 2, new bridge 3, right, are the custom networks on my host. So out of these 3, only new bridge 3 is being used in a running container. So let's inspect this network to confirm this. So docker network inspect new bridge 3. Okay, so yes, it is being used by the container test nginx. Now first let's try removing it in this state. Docker network rm new bridge 3. So we get an error message as network has active endpoints, hence cannot be deleted. This was kind of expected as well. I will stop the container now. So let's stop this container. Docker stop test nginx. Once the container is stopped, let me confirm it once. Okay, so it is stopped. We can try deleting it again. So let's try it this time now. So docker network rm new bridge 3, and this time it works. It allows me to delete that. Let's run the docker network ls and we can see that the new bridge 3 has been deleted. Now there is another concept here which is called prune. It removes all unused networks, that is those networks which are not referenced by any containers. So let's run it on our host now. So let's say docker network prune. Now this will give us a warning first. This will give us a warning. I select yes and it deletes the 2 unreferenced networks. Now I will run the docker network ls to confirm. Only the default networks are left on my host. So now we understand that we cannot delete predefined networks or any network which is being referenced by a container. Prune is to clear the system of all the networks which are not in use. Hello everyone. In this nugget, we will learn how to provide the custom network while initiating the container. There would be times when we need to specify more than one network to a container. So the objective of this nugget is to understand how this can be done. While running the container, we can only provide one network, which can be predefined network or a custom network. This can be done using the -net or -network option, as we have seen in the earlier videos. So let's go back and we will first create 2 custom networks here. So let's get back to our host. Docker network create. The driver will be bridge. We will also give the subnet for this. So subnet 192.168.0.016, and we will also provide the gateway, that is 192.168.0.1, and we'll name it as custom 1. Okay, so this is created. Now let's create the other one in the similar manner. Net docker network create. driver. Again, we will create of the bridge type. The subnet for this would be 172.100.0.0.16. Gateway would be 172.100.0 and .1, and let's call this one as custom 2. Now we will run Tomcat container using these networks. At the container run, we can specify only one network as we've seen. So let's do that. Docker run -itd-rm. Name will be your Tomcat1. -network will be custom1. We are binding it to that network. And let's specify the internal and external port numbers as well. So 1000 and 8080, and we'll call it as Tomcat1. Okay. So this container is now up. We can add more networks to this containers. For this, we will run the docker network connect command. So let's do that. Docker network connect custom 2, and we are adding it to Tomcat1. Okay, the command is successfully run. Now we can do an exec to this container. So let's do that. Docker exec -it Tomcat1 and bash. Now we are inside the container. We will run the command ip add show, and as expected, there are two network interfaces that are present here. So as you can see, and eth0 and eth0, eth1. H0 is in the range of custom 1 network and H1 is in the range of custom 2 network. So now we know that the container can only be run with one network. We can add more networks later, but there might be a case when you need to run the container only when 2 or more networks are already added to that container. In such a case, we will create a container with one network interface. So we won't start it yet, but then we will add more interfaces, and once we are ready with the number of networks, only then we will start the containers. So that will solve our purpose. We will try this. So let's say docker create -itd. Okay, we are not running it in detached mode, so no D. Name Tomcat2. Network will be custom 1. Then -p. This time we will give the external internal IPs port numbers as 3000 and 8080, and the Tomcat image. The container here is just created, it is not run. So if you run the docker ps now, this won't show up, and when I run docker ps -a, let's try doing that because this is not running. So if you want to see all of the containers, then we will say docker ps -a. This container is in the created state, not yet started, as we can clearly see here. Now we can add one more network to it in the similar fashion as above. So let's do that. Docker network connect custom 2 and Tomcat2. Now we are ready to start the container. We will run docker start Tomcat2. Okay, so if we run docker ps now, the Tomcat2 container is also in the running state. We will do an exec to this container. So let's do that. Docker exec -it Tomcat2 bash. Okay, let's run ip add show, and we can see that there are two network interfaces added for this particular one, which are added on this particular container. That's how we can add multiple networks to a container We can start the container when all the networks are added, or we can add a network to already running container. Hello everyone. Welcome to the fifth module of the Docker course. This module is about Docker images, which form the base of containerization story. It is very important from the certification exam point of view as well, because it constitutes around 20% of the examination questions. So let's have a look at the agenda.